Assalamu alaikum, Ahmed. How are you?
Walaikum Assalam, sir. I'm good.
All right. Okay. So why are you so late, Ahmed, in class? Hmm? We've already lost 10 minutes. Okay.
Oh, yes, sir.
Okay. Even Arhan has not joined yet. Okay. So please try to join the class on time because we lost 10 minutes already. So we are left with
Oh,
50 minutes only. Okay. So if you guys are late in the class, then the syllabus won't be completed in time, na? Okay. So
yes,
far,
sir.
yeah, just give me a minute. Okay, so we will continue as Arhan won't be able to join today. Okay. Anyways,
Oh, okay, sir.
so far we were talking about cubes and what are basically cubes. We started the chapter with it. Okay, so I gave you an example here. Suppose you are provided with a cube here. See, in the first case, you are provided with one cube. Okay, so its sides are 1 centimeter. Suppose I need such a cube in which the side measures 2 centimeter. So in order to form such a cube, how many cubes do I require? Like this cube, similar to this
Three.
cube, how many cubes do I require to form a cube in which each side measures 2 centimeter? Yes, Ahmed, for that purpose, what we
Sir,
did.
we multiplied, sir. 2 into 2 into 2.
Yeah, we
Or
basically
two.
found out the number of required cubes like this. Similarly, if the sides were to be 3 centimeter, then the number of cubes required were found out like this: 3 multiplied 3 multiplied 3. Why? Because on each side we are placing 3 cubes in this one. Now, see, this is
Yes,
the height of the cube. Okay, and this is the length. These are the length and breadths. Length and breadth.
yes.
Okay, so whether on length, breadth, or height, you have to place 3 cubes on each of the sides, right? So in total, you will see that you will require 27 cubes. What if the sides were to be 4 centimeter each? Then do tell me how many cubes we will require.
Um, sir, uh,
Miss Ahmed, that is quite
sir,
simple, no? Yeah.
fi- 5 or,
Yes.
sir, is it 5 or,
No, Ahmed, listen to question carefully, now. Look, in the first case, what is the side of the cube given?
1?
What is the side? It is 1 centimeter here. In the second figure, I required to form such a cube in which each side measures 2 centimeter. Whether the height of the cube, this height, whether the length, or whether this breadth here. So I needed how many cubes? I joined how many cubes? 8 cubes together. I
Oh,
joined 8 cubes together. Then I got such a cube in which each side was measuring 2 centimeter. Now I uh, uh, I needed to make such a cube in which each side measures 3 centimeter. Okay. So for that purpose, how many cubes I need to take? Look, we are not taking this cube as the standard here. All the bigger cubes are made out of using this cube which measures 1 centimeter, whose length, breadth, and height measures 1 centimeter. So this cube has been used to make this one also. So how many cubes do we require to make a cube in which each side measures 3 centimeter? So for that purpose, on the height, length, and breadth side, you need to put 3 cubes, so that in total you get 27 cubes.
oh, okay, sir.
You must have played with the Rubik's cube.
Um, yes,
Okay.
sir. Have.
So think of this figure as a Rubik's cube. Okay, so I'm now saying you that for to make such to get such a cube in which each side now measures 4 centimeter. So in total, how many cubes will be required?
4 or
No, Ahmed, you're not getting it again. No, look, for the first one, we simply have one cube. For the second figure, we found out this 8 cubes how? By doing this calculation, na, 2 multiplied 2,
Yes,
that
sir.
gave me 8 cubes.
54, sir.
No, 4 multiplied 4, that gives you how much?
54.
54. Ahmed, your calculations, what happened to your calculation?
Oh, sorry, sir.
16 multiplied 4, that will give you 64. Okay, I guess you have not been practicing enough questions at home. Okay, so please work on your basic calculations, right?
Yes, sir.
Okay, now explain to me what we just did here. Just explain it to me. Then I will get to understand that you got the concept.
Oh, okay, sir. So we have taken understanding the cubes by 1 centimeter cubes takes 1 cube, 2 centimeter takes 8 cubes, three
Hmm.
centimeter takes 7 cubes. We
Hmm.
by the cube roots of cubes, and the four
Yes,
centimeter takes 64.
yes. So 64 cubes of what centimeter? This one, no? Okay.
Yes.
So all those
Four,
64 cubes, their length, breadth, and height each measures 1 centimeter. So if you were to arrange 64 cubes, then we will get such a figure in which each of the side measures 4 centimeter. Right?
okay, sir.
Okay. Now, these numbers which you saw here, like 1, 8, 27, 64, these are in fact called as what? If you were to move further, 125, 216, these numbers are called as perfect cube numbers. These are called perfect cubes or cube numbers. Just like in square and square roots, we had perfect squares now, like 4,
Yes.
16, right? 9, 25. These were the perfect squares. So these numbers are called as perfect cubes. Here, this 1, 8, 27, 64, 125 or 216. Okay. But the question is, how do we test whether a given number is a perfect cube or not? That is the question here. So suppose I give you two numbers here. Okay, Ahmed.
Okay.
I am giving you a number 27 and I am giving you a number, let's say 68. How would you tell which one is a perfect cube here?
By uh,
Just recall the process of prime factorization of a square numbers.
oh, so it prime factorizes in digits, sir.
Prime factorize these digits. Okay. So if you were to prime factorize 27, it will be 3 multiplied 3 multiplied 3, right? And what about 68? Prime factorize 68?
Sure, sir.
Yeah. Yes. What are the prime factors of 68?
Sir, I'm still solving.
Okay, okay, okay. Take your time. Yes, Ahmed. Did you got the answer?
Wait, sir, I'm still solving it.
Okay,
Just
okay.
Sir, what is
Okay, look, prime factorization, that is quite simple. You simply
sir.
find you simply take a divisor and divide it. So that gives you 34 here. Okay, now 34 will be divided by 2 by 17 times, right? Now it cannot be divided any further.
Yes,
Okay,
sir.
so the prime factorization here is what? 2 multiplied 17. Now
Yes, sir.
you will basically stop at this step, no need to do further. So that is the prime factors of 68. So notice the prime factors of 27 and 68. What do you observe in between the two?
The digits are different, and
The digits are different, and the same digit occurs 3 times for 27, while uh,
and,
the
and
same digits occurs for 3 times for 27, this 3 here, while there is no same occurrence of the digits in 68. Like 2 occurs 2 times while 17 occurs only 2 times, right? So this is
yes, sir.
not a perfect cube, while the first one is a perfect cube. Okay, now see for other numbers, like see for 27 see for this number 64.
Okay, sir. 64 is 8 into
64,
8. 8
no,
into
no,
8.
no, no, you need to take the small prime factors.
Oh,
Okay,
okay, okay. Okay, sir.
try representing it in the form of like this,
Yes, sir. Yes,
just like how we represented it, like here, and see for 1000 as well. Okay.
Sir, 2 into 2 into 2 into 2 into 2 into 2.
Okay, we can do it like that. 2 into 2 into 2, and then again 2 into
Yes,
2
and
into 2, right?
2.
So we get
Yes, sir.
2 pairs here, no? Okay, so
Yes,
here
sir.
the
3.
number 2 occurs, not 3 pairs, since we are dealing with cubes here, no? So you will take
Oh,
number in pairs of 3, right?
okay.
Okay,
Yes.
so first basically what we do, first we prime factorize the number and then group triplets of the same prime number. So we have group triplets of 2 here 2 times. So it will be what? You will take single number out of the triplets, that is 2 here and 2 here. So 2 multiplied 2, that gives me 4, right?
Okay.
Check for this 1000 also.
Sure, sir.
Okay. You can take bigger numbers as well. Okay, you can take bigger numbers also. Okay, although in the prime factorization it's better that you take from a smaller number. Okay, so it's better if you take the smaller number. Let's stick to the step. Hmm. Okay, so when you will find it out now, it will be like this: 2 multiplied 2 multiplied 2, and
And
then 5 multiplied 5 multiplied and 5,
5. Yes.
isn't it, Ahmed? So
Yes,
you
sir.
get 2 triplets here of same numbers. Okay, triplets of 2 and triplets of 5. So take out one number out of the each triplet, that is 2 multiplied 5, hence
And
it's 10. Okay, so how do we check whether a given number is a perfect square or not? Like this here, right? If the prime factors occurs in pairs of 3, in groups of 3, then it's a perfect
perfect.
cube, right?
Yes. Perfect.
So in between 1 and 1000, you will find out that these are the only 10 perfect cubes. If you were to find the perfect cubes in between 1 and 1000, okay, you will find out the only perfect cubes that exist are 1, 8, 27, 64, and up to 1000.
Oh,
Look,
okay.
see, your if you see the number 1 and the number 1000, right? Let's
Yes.
write all the cubes that will exist between 1 and 1000, right?
Okay.
So let's write the cube of 2. What is it going to be? 8.
Cube of,
Yeah, cube of 2 is going to be 8 now. 2 multiplied 2 multiplied 2.
oh yes, yes, sir.
Yeah. What about 3?
27,
27. What about 4?
36.
No. 4.
Oh,
See the number, it's 4.
okay. 20,
Wrong.
31.
Wrong, again wrong. Look,
Oh,
when you are required to find the cube of the number now, if you're given with any number a, you simply find its cube by multiplying the same number by 3 times. Okay.
oh, okay, sir.
So here it's going to be 4 multiplied 3 times itself. So that gives you
64,
64. Good. What about 5?
50.
Wrong. How come it be
Oh,
15 or 50?
sorry.
Yes. 5
It
multiplied
is
3 times
125.
125. Good. What about 6?
6 is 216.
216. Good. What about 7?
7.
Yes.
7.
Yes, Ahmed. What about 7?
It's
Have you taken
30
a pen or paper or not? Keep a
I
pen
have
and paper with you. Okay.
times 343.
343. Good. And what about 8?
And is some 51. 512.
512. Good. And what about 9?
Okay. Solving it right now. 739. 729.
729. Very good. Okay. And this number 10 is the cube of this number 1000 is the cube of 10 here, right?
Sir.
That is obvious here. So we can see these are the only perfect cubes that exist between 1 and 1000, right?
Yes.
In fact, 1 and 1000, they also are perfect cube. So we can include them as well, right? Okay.
Yes.
Okay. So far everything's clear.
Yes, sir.
So you know how to find a cube and how to spot whether a number is a perfect cube or not. Just you will prime factorize the number. Okay, group the numbers. If you try to group the numbers, if you get to see the triplets, then it will be a perfect cube. So suppose if you
Yes.
get the grouping of the numbers like this: 2 multiplied 2 multiplied 2, and then 5 multiplied 5. So is the number going to be a perfect cube in this case? If you
It is
look
5
again,
into
look again at the prime factorization of this number x.
x. Oh,
Look
no,
again.
no, sir. No, it's only 2 5. There
Yes,
should be
there are
3.
only 2 5s. It has to be 3. Okay. All right then.
Yes.
Now, let's talk about the smallest divisor or multiplier to form a perfect cube number. So for example, see this number x here, which has its prime factorization like this, now 2 multiplied 2 multiplied 2, and then 5 multiplied 5. So this is obviously not a perfect cube. So in order to make this number a perfect cube, what needs to be done? It needs to be multiplied with 5, no?
Yes, sir. It needs to be multiplied with 5.
Okay, so that will give me 2 triplets here. Okay, so a non-perfect cube number can be made a perfect cube number either by multiplying or dividing the number by a certain number. Okay, So let's first talk about the smallest divisor now. Smallest divisor. Okay. So let's take example of a number 686. Okay. And let's prime factorize this number. So what is the prime factorization of this number going to be, Ahmed?
Prime factorize. So I have to solve it. Wait.
Okay, okay.
Three, 3, 4, 3. Mm,
Okay, I've given you a hint here.
okay, so
And Ahmed, in the previous chapter, after 6.2, you haven't sent the assignment.
oh,
There were more exercises, no?
6.2, sir.
Yeah, you sent 6.2.
6.4.
Yes. Have you included 6.4 also in that PDF?
Sir, I'm still solving 6.4, sir.
Okay, okay. So I guess you're not having any difficulty in solving the exercise. If you are, okay, okay, okay. So, try to send the assignments as soon as possible, because before you summer vacation ends, we will try to cover more chapters, some more chapters. All right. So
Oh,
that
okay, sir.
when your school opens, you will be ahead of what is going in the school. Okay. Now, what is the prime factorization of the number 686?
Yes, I'm still solving.
Okay, okay. So just need to divide the number 343 by 7. Okay, just simply divide it. It should not take too much time.
Sir, it's 2 into 7 into 7 into 7.
Yes, it's 2 into 7 into 7 into 7. Very good. So notice the number 2 here. It does not occur in a triplet, right?
Yes, sir. Yes, sir.
While 7 occurs in a triplet.
So,
Does
yes.
not occur in a triplet here, right? So what needs to be done? How do we make this number a perfect cube now?
By multiplying two times again.
Just by multiplying it by 2 times again. So here we are first not, let's first talk about multiplier. Okay, then we will see another questions. Okay, smallest multiply. So if we were to multiply it with 2 times, then will it not become a perfect cube?
It will, sir.
It will, right? So we
Yes.
need to multiply the number with 4 here. So smallest multiply for this number is 4. So if you were to multiply simply 686 by 4, then you will get get it to a perfect cube, right?
Yes, sir.
Now let's have look another number,
Okay.
smallest divisor. So in this case, we saw that we can multiply a number with multiply a number and make it a perfect cube. Okay, consider a number 3087. Okay, first we will try to find its prime factors. So what are the prime factors of 3087? What is it going to be? Let's try to find it out. Okay. So first it will be getting divided by 3, right? Okay.
Yes, sir.
Again, it will get divided by 3 by how many times? 343, right? And then you divide it
Yes,
by
sir.
7.
7.
So the prime factorization is like this: 3 multiplied 3, and then you get
Into
triplets of 7. Okay. So now in this case, we see obviously the number is not a perfect cube because 3 occurs in pairs of 2 while 7 is occurring in pair of 3. Okay. So if the number 3 was in pair of 3, it would have been a perfect cube. So if you were to divide this number by 9 here, if you were to divide the prime factors, its prime factorization, if you divide it with 9, so it gets cancelled out now. So we are left with
Yes, sir.
7 as triplet here. Okay. So simply divide the number, this number by 9, and then we get it. Then we can make it into a perfect cube. So number can be made a perfect cube either by multiplication or either by division as well. It depends on the question what method we need to follow, right? So if you see now,
Yes.
if the question was like this, make the numbers a perfect cube number by multiplying it. So in that case, what needs to be done to this number?
Yes, sir.
If the question was like this, as I said earlier, that that a number can be made a perfect cube either by multiplication or either by division. Okay. So this number 686 here, we were multiplying it with 4 here, right? But it can be divided by 2 as well. That will eliminate 2 from here and you are left with 7 here only.
Yes, sir.
Or same is for 3087 also. Here we are dividing it with 9, but if we were to simply multiply it with 3, then in that case also it will become a perfect cube because you get triplets of 3 here, right? So
Sir.
which
Yes, sir.
approach you take in solving the question, it entirely depends what the question is asking, right, Ahmed?
Yes, sir.
Okay, very good. Now let's move ahead. That is clear now?
Yes, it is.
Okay, okay. Now let's move ahead. Now let's talk about some properties of numbers, properties of cubes of numbers. Okay. So if you see the natural numbers, okay, if you see all even natural numbers like 1, 2, 4, okay, 4, 6, 8, 10, 12, and if you were to see the cube of all odd numbers, like let me write the numbers here: see 2, 4, 6, 8, 10, 12. Okay. Then take odd natural numbers like 3, 5, 7, 9, 11, and 13. And let's write its cube numbers. Write its cube. It's going to be 8, 64, then 216, Ahmed, right?
Yes.
Then
Yes, sir.
512, then you get 1000, and then you get 1728. We are trying to find its cubes now.
Yes, sir. We are.
Okay, similarly, find out the cube of odd numbers also. So 3 cube is equal to how much?
Sir. 3 is 27
27,
and 125
125, good.
and 343.
343,
Just left 9 720. No, 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 I mean
729, good.
yes, and
And
11.
1331.
Oh,
Okay. And what about 13?
and the
See if it's 2197.
Okay, sir.
Okay, check it now. It's
Okay.
yeah. Yes, that is 2197. Okay.
Okay, sir.
So what do you notice in the unit digit place of the odd natural numbers and the even natural numbers? What do you notice here?
So the natural, I mean the even numbers are ending with an even digit, and the
Yes,
odd numbers ending with the odds.
exactly. See, they are ending with the even number of digits. So what
Yes,
do
sir.
we conclude from here? That cubes of the numbers ending in digits like 1, 4, 5, 6, and 9 are the numbers ending in the same digits. Okay.
Yes.
Now we are discussing actually the first property. So first get done with the first property, then we'll move ahead. So cubes of all even natural numbers are even, right?
Yes.
So whether you see 8, 64, 216, 512, 1000, or 1728. So the number, the even natural number and their cube, even its cube is going to be an even number, right?
Yes, sir.
Their cube is also even number. While see the odd numbers 3, 5, 7, 9, 11, and 13. Are their cubes odd or even?
Uh, they
It's
are even.
20.
That's
No,
all.
that's
That's
odd,
all.
no?
Yes, sir.
27 or 125 or 343. So we conclude from this that cubes of even numbers are even and cubes of odd numbers are odd.
All.
Right. Now see
Yes.
next property. Cubes of the numbers ending in digits 1, 4, 5, 6, and 9 are the numbers ending in the same digits. What do I say? What do we mean here? See. The second property basically read it. What does it says?
Second property, cubes of the number ending in digits 1, 4, 5, 6, and 9 are numbers ending in the same digits.
Okay. So cubes of the numbers ending in digits 4, 1, 4, 5, 6. So these are number. So we have taken the number as per the property given here,
Yes,
right?
sir.
And
Yes, sir.
let's take another number as 9 as well. Okay. Now write its cube. It is 164. Then it is 3375. And what about the cube of 16? What is the cube of 16?
Cube
Quickly,
of
yeah,
16,
let's quickly find it out. 196 multiplied 16. That gives you how much? Find this one.
196 multiplied by 16. Okay, sir.
Yes, find this one. Okay.
3136.
That is
3136.
3136. Okay, what about 9? It is 729. So Ahmed, what do you notice here in the unit digit of the numbers? Like the unit digit of the number here 1 and its cube, both of them are same.
Yes, sir.
Same is for 4 also. Its unit digit is 4 and the unit digit of its cube is also 4. What about
Yes.
15? Its unit digit is 5 while its cube is also 5. Same goes for 16 and
5.
9 also. Okay. So
Mm.
second property says that cubes of the number that ends in digits like 1, 4, 5, 6, or 9, their cubes are also having the same digits. Okay.
Okay, sir.
Now see another number, another property, which says that cubes of the numbers which ends in 2 and 8 will in 8 and 2. So take a number here. Let's take a number
Mm.
12,
Okay.
right? It is ending with its unit digit is 2. And let's take a number whose in digit is 8. Okay. So let's cube the numbers. So 12 cube gives me 1728, while 8 cubes give me 512. So you tell me what do you observe in the cubes of two numbers? What is the interesting pattern here?
Uh, uh, mm, sir, are those
Yes. Notice something here?
Yes, sir.
Yes.
These digits are coming here opposite digits.
Yes. So here you notice that cubes of the number that ends in 2, its cube will end in 8. While cube of the
Okay.
number whose unit digit is 8, its cube will end at 2. Let me repeat it. Cubes
Okay.
of the number whose unit digit is 2, its cube's unit digit will be 8. And cubes of those number whose unit digit is 8, their cube will have 2 at the unit place.
Yes, sir.
Check for one more number. Write the cube of 2 and write the cube of 18. And do tell me if you observe the similar pattern.
Oh, okay, sir.
Yes.
Yes, sir.
Yes.
5832 for 18 square and 2 for 8.
What is the cube of 18?
5,
Yes.
3, 8, 5832, sir.
5382. Right. So that is correct for others numbers as well. So that is property number 3. You got this one, no?
Yes,
Okay.
sir.
Now let me create some space over here. Okay. If you want, you can take a screenshot of this one. Okay.
Oh, okay. Okay.
And to tell me, so far, have you been taking notes of all the classes now?
Yes, sir. I
Okay.
am.
Okay. Okay. Just write the highlighted points. Okay. Like
Okay.
here, you need to figure down all the properties of cubes of numbers in your copy. Okay.
Okay.
Okay. Now, see property number 4 here. What does it say is that cubes of the numbers which ends in digits 3. So let's take a number which ends in 3. For example, let's take the number 3 itself.
Oh.
And another number which ends in 17. Let's take 7, which ends at 7. So let's take 7 and find out their cube. So that is 27 and that is 343. Now in this one also we are observing the similar pattern, right? The
Yes.
cube of the number whose unit digit is 3, it's ending at 7. Its cube is ending at 7, while the number whose unit digit is 7, it is ending at 3. Its cube is ending at 3, right? So same pattern is for 3 and 7 here as well. Okay. Now see for a bigger number. 13 is cube and 17 cube.
13.
Okay. Yeah. See if it is true for these two numbers also. Is it 3143?
Yeah. 3,
Check
1,
for
4.
it. Yes. Find
Okay.
it out. Okay.
Sir, the first one is 2197, and it is
2197.
following the property, sir.
And what about 17 cube?
I'm still solving it, sir.
Okay, okay.
So 4913.
4913. Good. So notice in these two numbers also the unit digits ends with 7 for a number whose unit digit is 3 here. Okay. And for 17, since its unit digit is 7, its cube is going to be ending at 3 as per the property. Okay. Now let's move on to next property. Next property says that if you have a number 10, its cube is obviously 1000. So what do we see here? That the number which is ending in a 0, like this number 10, it is ending at 0, meaning its unit digit is 0, then its cube will end in 3 zeros, right?
Oh,
So
okay,
10
sir.
cube gives me 1000. So here the unit digit is
So this
0.
property is, yes, sir.
It's 0. So its cube
Is
is going
also
to have
three
3
zeros.
zeros. Yes, 3
Yes,
zeros.
sir.
Same is for other numbers also. 20 cube, that
1000.
is
Eight.
8000. Here also 3 zeros are there. Okay. Now take the screenshot of this one as well.
Oh, yes, sir. Screenshot. Okay, sir. I've taken the screenshot.
Okay, now last property is pretty simple. The cubes of negative numbers are negative and the cubes of positive numbers are positive. That is pretty simple. Okay. So what does this shows? That negative numbers may also be perfect cube. See the last one. So for example, I have got a negative number -5. Its cube is going to be -125, right?
Yes, sir.
So one thing you need to take care of here, that this thing basically shows that cubes of negative numbers are also perfect, right?
Yes, sir.
So -129, -125 can also be prime factorized like this, minus and then
Yes, sir.
5 multiplied 5 multiplied 5. Okay, that is -5.
Okay.
See, we are getting a triplet here, and you get -5 as its cube root. Okay, now I have some questions for you. Let's quickly do this one. Which of the following is false? Out of these four statements, which statement is false here? Read them carefully.
Okay, so first one is true, sir.
Cube of any odd number is odd. That is true. Good.
And the second one is true also. Also,
Hmm? Yes.
the second is true, right?
Yes.
First single digit number maybe I think. No, no, sir. This is false. C is
The
false.
cube of a single digit may be a single digit number. Think again. Think
Mm,
again.
okay.
Take examples and see if the option is correct. The cube of a single digit number. What are some single digit numbers?
Three,
1,
five.
2, 3, 4, 5 up to 9. So what are their cubes? 1, 8, 27. So see, for the first two numbers, their
One.
cubes are also single digit number, no?
Yeah, the first two.
Yeah, only the first two.
Yes, only the
Okay, so
first two.
that is also true. Okay, then the first three options are correct, then definitely the last one is going to be wrong, no? So
Yes.
there is no perfect cube which ends with 8. We just saw the cube of 2 ends with 8, no?
Yes, sir. The cube of
Okay,
two
and
and
it's a perfect cube,
sir,
right?
the it's,
Yeah. Yes, you were saying something?
the cube of 12 is also ending with 8.
Exactly. That is 1728.
Yes, sir.
Okay, so they are bigger numbers as well. Now, which of the following is a perfect cube here? That you can check using the prime factorization method. Okay, check it and do tell me.
Okay, sir, sure. Sir, the first one is in the prime. I mean, it's not the perfect cube. The A
Okay,
is not the
okay. So
two.
what are its factors? What are its prime factor?
3 into 3 into 3 into 3 into 3. One 3 is missing, sir.
Yes, 1 3 is missing here. Good. What about 216?
I am solving it, sir.
Okay.
Sir, this is the perfect cube.
Yes. Right.
Yes.
Okay, so it is the cube of 6.
Yes, it's
Now check for number 392.
392, sure, sir. So this is also not a perfect
Okay,
cube.
what is its prime factor?
2 into 2 into 2 into 7 into 7.
7 to 7. So 7 does not exist in pair here.
Yes, sir.
Okay, good. 8640. What about this one?
Okay, sir. Solving this. Um, Sir, 2 into 2 into 2 into 2 into 2
Hmm.
into 2,
Hmm.
3 into 3 into 3. So there are,
There are 2 3s.
yes, sir, there are, no, sir, there are 3. There are
Okay, let me check it.
3 trees. Trees of 2 and yes,
Okay, so you are getting its prime factorization like this. 2
yes, sir.
multiplied 2 multiplied 2
3
again
pair,
2 3 times, right?
yes, sir. And
There
3
are,
is one
yeah.
pair of 3, and there's 5 of them.
Okay, so 5 is not in groups of 3. It's not in
Yes,
triplet. That is why
yes.
this one is also not a perfect cube. So the only
So,
number is which one?
2 and 6.
216, right? Okay. So your task is to write the numbers from 1 to 20. Okay. And write its cube as well. Okay.
Right now, sir.
No, right, not right now. That will be your assignment. Okay. So
Okay,
from
sir.
0 to 14 and then from 15 to, let's see where, how long it goes.
20. Oh,
Up to
29.
29 you have to write its cube. Okay, and try to remember cube up to 15. That will save your
Please.
time in calculations. Okay,
Okay, sir.
you have to remember cubes up to 15, so, because that is going to save a lot of your time in calculation. Okay, Ahmed.
Okay,
Okay,
sir.
so today we discussed about the different properties of cube numbers. Okay, and
And
we also talked about the smallest multiplier and divisor, and how to basically check whether a number is a perfect cube or not. Okay.
yes.
Okay, so revise all these things.
Okay,
In the next class I might ask the properties of the cube numbers. Okay, that's
sir.
it for today. Okay, so the assignment is going to be this one. You have to solve, you have to memorize it and write
No,
them as well. Okay.
okay, sir.
Okay, then that is it, and we will meet in next class then. Okay.
Oh, okay, sir. Allah
Okay
Hafiz.
then, Allah Hafiz.